Hello, welcome everybody to the lecture series Quality Management and Applied Statistics. My name is Ulrich Weber and I'll be in charge of the statistics part of this whole lecture. Before we start, just a few things. Because of our special situation at the moment, I'll be putting these videos online for you on Moodle, so you can see the slides and hear my voice with all explanations and everything I would say in a normal lecture. I'll also scribble into the slides and put everything I would normally put on the blackboard on the video screen. You can also download the slides in parallel, so you've got them for your records and learn from them. And there will be each week or each other week there will be problem sets for you to work on by yourself to get used to the sorts of problems that will be questions in the exam. Okay, in total there will be 5 lectures, each divided into multiple parts I'm gonna record separately. Alright, let's have a look. Statistics. So why do we need statistics? Well, statistics help us a lot when we want to extract meaning from data. Data is being recorded everywhere, especially in digital times. There's tons of data of where we move, like what we like to buy, shop, drink. There's data about diseases, there's data literally about everything. A lot of data seems random or is random sometimes, but statistics can help to discover patterns behind it. And in these patterns we can see a certain behavior. We can assume there's a model behind it, some certain mechanism, and what we then want to do is predict with this model what sort of data we would see, and then compare whether our model is right with some new data. And this way we can confirm or reject hypothetical models or hypotheses. So all of this we're going to do. So what do we learn from data? A few years ago I was in Perth, Australia, and on the metro line they put these little graphs on there. Basically it's data about, let's look at the first one here on the right, about punctuality. So if we zoom in, were we on time, and they've given us the more or less raw data. We see we're somewhere in the 90s, 90% and above. There's a little blue line here. That's probably the average. We're going to talk about averages in a few minutes. 95% punctuality sounds pretty decent to me. So this is one of the uses of data. We can see how good the system works. Great. But there's another. So that's the first graph here on the left, but there's another one here on the right. Let's have a look on this one, and this is the safety and security incidents graph for the 2 years 2014 and 2015. 2014 in orange, 2015 in blue. And it titles, "Are we changing behavior?" And then my question would be, are they? Is the metro line becoming safer or not? Or is it getting worse? What does it show us? And I found it quite funny, so that's why I'm showing it to you, because they've given us the raw data more or less, but they've missed the interpretation of it. It's up to you, it could mean anything. And that's where we want to get to in this course, that we kind of take data like this, and then we could have a hypothesis yes, it has become safer in 2015, and we could test it with this data and we would get like an answer saying like there's a 60% chance that it hasn't become safer or something like that. Okay, so let's abstractly look at this. This just like the broad overview over like the whole thing. So we talked about data, and our first step will be we're going to take the data and describe what we see. So we talked about the mean value. Show that to you on the next video actually, within a few minutes time. We can extract other useful bits of information like variances and correlation coefficients and all that sort of stuff. But we're always just describing some numbers. What we're then going to do is we assume that this data that we have is not just like, doesn't just happen, it happens with purpose. There's like a model or like a population of data behind this, and we've just seen a bit of it, like a sample, you know, like rolling the dice 10 times, that's our data, but we know there's an actual die that we can look at and find out whether it's a fair die or the numbers come with the same probability or not. You know, we're looking at what's behind the data. That's the interesting bit. And then by exploring this, we're going to think about, you know, for our sample that we have, sample 1, it's just one of many samples. We also could have had another sample or an even different sample. So we're going to try to use these descriptions of sample 1 that we have to kind of think about other possible samples and what they would look like to find out how strange our sample is. And then if we do something to our model, to our population, or if, you know, like in medicine, if we like develop some treatment for something, we get like two samples, one group that hasn't had the medicine, one group that has had the medicine, and then we say, oh, let's compare them. Is there a difference? Does the treatment cure anything? And if it cures, it means like the model, meaning the body has changed in its function, it's improved. So then the question is, how can we compare these two data sets, these two samples? So this is like the outline for the whole statistics part. In terms of lectures, it will be broken down to this. So one is descriptive, we just describe data. Then we talk about probabilities. We need this as like a tool for the random variables in part 3, where we then talk about the model behind everything. We need, in number 4, we need then all the distributions, because every statistical model has to follow a certain distribution, and depending on what we work on, that's going to be different. And then 5th lecture, last one, we're going to define confidence intervals and do some hypothesis testing. And then we're like pretty well set up with like basic statistics for everything that we need in quality management. All right. Please listen to part 1 in this next separate video. Alright, see you soon.